to collaborate actually between the policy maker level and the planning authority level is a distinct challenge, I think. And our building stock model, hopefully, Felix will confirm so, was sort of a catalyzer also to bring these two different levels together. And what you actually have in cities and probably also in countries is the situation that you have policymakers or even NGOs that are setting far-fetched goals, climate change mitigation goals on the one hand side, here on the very left-hand side, and then you have people such as you that need to implement these kind of goals. And what often is lacking is a kind of a quantified tool that links the goals and the necessary measures to implement these goals. We have heard of a CO2 tax, for instance, so the question would be, how much CO2 tax do you really need? How much additional energy efficiency measures can you implement, for instance, through building code? What is the effect of local energy networks such as were presented today in several instances? And to bridge that goal between this gap between the, sorry, it doesn't work, but you know what I mean. The bridge, the gap between the policymaker, the urban energy planner, and the real building stock. That's the goal of our building stock model, as we call it, which is an instrument for conceiving and planning energy, a tool for conceiving, planning, implementing, and hopefully also monitoring energy and climate policy goals. And what it does, our building stock model, is actually describe the status quo. So without knowing where you are, it's difficult to find out what it means to reach a far-fetched goal. So the starting point is very important. Having an inventory, having an information about how your building stock is consuming energy, how much of the building stock is already renovated in the past, for instance, how much remaining potential you have, how the energy performance gap could impact on your goals, for instance. A subject that is discussed widely, especially in the Netherlands, by the way. So starting with the inventories, then as Felix already pointed out, you have different scenarios where you want to or could go into the future, and policymakers' task is actually to create to a certain extent the future. And so the question is, in which future would you like to go? And therefore scenarios are very important because they showcase actually the implication, the necessary measures to reach a certain goal and to go on a certain pathway of a given scenario. So this is just an image how that could look like at the end if it's nicely made in terms of graphics, where you have information about the current building stock. Of course, you don't have detailed information of each of the buildings, and that's why we are here actually to talk about data. And if you talk about data, it's also very much about data gaps, and a modeling framework allows also actually to fill data gaps and to impute missing data, to complete data that are available at different forms. For instance, you could have aggregate data on energy consumption or on retrofit rates, but not on the individual building level. So the modeling also helps actually to fill data gaps. And at the end, the scenario tells you how a building stock state could look like in the future under different conditions. Of course, each and every individual building is not predefined by such a modeling. It's just an idea of how it could look like overall. And of course, we want to go as concrete as possible. So before then really talking about the database, maybe first about the procedure, how the tool was typically applied within this case study in the city of Zurich. I think Felix Schmid formerly very nicely presented what was the outcome of this modeling work. So here on this slide, I just summarized very briefly and sketchy in a simplified way what could typically be the 3 steps that you could undertake if you're starting from scratch. Of course, many cities, especially those in the room, they are not starting from scratch, but we might have the situation where you have just an aggregated goal. And so the question is, what does it mean for the city as a whole? Which kind of measures do you need to then finally achieve the far-fetched mitigation goals? That's actually depicted here on that slide where we implement different measures, and each of them is contributing to the final goal. And at the end, you sort of have a feasibility scenario that showcases how a certain goal on a strategic level could be achieved. We are still on the level, on a scale of the city as a whole, and not on the level of individual buildings, but it also already allows for understanding what it could mean actually at the end of the day. The next step would then be what Felix, I think, also nicely explained, that you match energy demand and energy potentials of both existing energy infrastructure, such as district heating, but also very much the local renewable energy sources that are available. So to bring together on a neighborhood scale demand and supply or potentials. That's second level of concretization, substantiation, I would say, where you get a more concrete idea how an implementation of a far-fetched goal and strategy could look like. As you know from your own cases, a city is not a homogeneous abstract thing, but it's very different. It has a different density of construction of buildings, has different potentials. You have rivers, you have ground source layers, and so on. And the cities need to be dismantled into these different neighborhoods, as we call them. And actually, these neighborhoods here, they are not the political neighborhoods of, let's say, districts, but they are really the boundaries of meaningful homogeneous regions where demand and supply have some homogeneity within that boundaries. So that's the second step. The third steps in the approach would be that you finally deliver data really for the sheer planning process of, for instance, district heating companies or for new energy service providers, that they are able to plan their network. And in Zurich, we are not only talking about district heating network of the first or second or third generation, but also of the fourth and fifth generation, where we actually combine the heating and cooling demand on an ambient temperature network, for instance. So in this last chart, you see that we have a combination of the energy demand for heating and for cooling at the same time, which allows you for identifying which are the areas that are suitable for such a far-fetched combined heating and cooling network. And whereas in other regions, it's probably only a heating network itself, for instance, where you have mostly residential buildings. So the requirements that the city of Zurich had for such a tool, and by the way, also, of course, other clients had similar or additional requirements. You can see on that slide, it's about 3 points that are important to take away here. First of all, we wanted to have a bottom-up approach where we represent the different building elements, such as facades, windows, rooftops, etc., because many measures are bound to either building elements, including building including building technologies, when it comes to heating system choice, for instance. So technology and building element based. Second, I think quite obvious, it should be GIS bound in order for you to make this merging between energy demand, energy supply, energy potentials. It allows actually finally to make a sort of a multi-layer analysis, as I think came apparent also from Felix' talk earlier this afternoon, where you have the layer of, for instance, patrimonial protection, the layer of available heat sources, the layer of densely populated buildings, the layer of current district heating network, and so on and so forth. And by superposing these different layers, you can then start identifying the different zones to end up on these maps Felix has shown earlier in the afternoon. Then when it comes to results, for the city of Zurich, it was important to have an answer, of course, in terms of energy and emissions, direct emissions from heating systems. But we haven't talked about it so far, also about LCA, material use. So the concept of the 2000 watt societies, also including actually embodied energy and the embodied emissions. So if you add insulation, you also add embodied energy, and this embodied energy is also taken into account in the different scenarios. Other clients had then also a need for understanding what is the costs of different scenario, what does it actually imply to implement a scenario, what does it imply to implement a CO2 tax, we have heard. So the model has actually a decision model inside, and we can model the effect of subsidies or CO2 taxes, for instance. Then very much it should represent the current building stock, I already mentioned it, and should be able to calculate long-term scenarios. So the typical results of of this tool, the building stock model, you see on that slide. So it's about representing, of course, the most important inputs. So you can also just have an interpretation of the meaning of your results if you also understand what was actually on the driver's side. So of course, if you have more population, it means more building, it means more heated floor area, it means more cooled floor area. So you need to be able to represent this as an output as well, be it as in terms of tables, in terms of figure, and as you have seen, the benefits of maps cannot be underestimated actually. And then we can choose across different differentiation. So we could say we will only want to see residential buildings, or we only want to see cooling in office buildings, or we just want to see different policy scenarios. We want to have the city as a whole, or we want to deep dive into zones, into streets actually. I think besides of this hectare grid, it's often more important for planners to actually have street layers, boundaries around a certain street grid, because grids are usually built into the street. So just to give you another example of a result of these case studies in Zurich is actually, here you can see the change of the energy demand for heating in between 2010 and 2050. And on the left-hand side, it's so-called the reference scenario, where you could argue, yeah, not so much changed. Let's continue with our current district heating system. Let's continue with our gas supply. The economics is not really endangered. However, if you then look on the right-hand side, where we have the efficiency scenario, the energy demand is reduced actually in most of the area of the city. Although you still have some regions where it's even increased, and that's the regions where you have a development of more density, where you develop the city, as Felix mentioned, an increase of the density, because somewhere the buildings need to be somewhere at the end of the day, these 100,000 inhabitants as well. So just to also go a bit more into the quantitative side, you see here the comparison of the demand as the green bars and of the local and extended potential of renewable energy sources as the yellow and orange bars. And after the demand has been reduced, because we are here in the efficiency scenario, it's just about feasible to reach this 2,000 watt society goal and to supply actually the demand of the buildings in the city of Zurich. So it's not a free lunch, but as we showcased with this building stock model, it's feasible. And that was a very important message, of course, also for the policymakers. So how we do that? So first of all, we need a modeling concept. I've talked a bit about it a little bit already. So it's a building stock model, meaning we represent the different buildings. We have an energy balance calculation engine, just state of the art. We distinguish between the different use cases in the building, actually the electricity consumption, which is also represented, not only heating and cooling, but including electricity for lighting, for ICT, for processes in the buildings. That's as well part of the consideration, because finally this is also energy that is consumed, and potentials for renewable electricity are also limited, especially in Switzerland. And so that's why the buildings are also represented in their mix of how they're used, as, be it hospitals, office buildings, retail shops, and so on. So what we need actually is a calculation engine for all these different energy uses, what we have developed then. And then you need the data to describe this energy balance or energy calculation machine, so to say. So what you have, of course, is as a main drivers are the buildings as such. So how many floor areas heated, how are these buildings, what is the fabric, what is the size of the buildings. So there comes the either you have a zoning map where you know how tall the buildings are, or you have a 3D model in the different city that you use just to describe the building envelope. Then the population and the employee and their growth actually determines how much the city will be growing. The buildings that are needed for taking up this population growth are then built by the model where you have still available possibilities, be it through roof extension or lateral extension in the case of Zurich very much, because we don't have free parcels, as Felix mentioned. Then, of course, you have the potential where you mostly a GIS analysis, for instance. You have the norms and standards to describe how much energy you need per square meter, floor area for lighting, and so on. You have technology data where you describe heating and cooling systems in terms of their costs and of their efficiency indicators. And you have, for instance, you might have database from the inspection of ventilation system, of heating system that is actually available at some authority level. And the goal here is actually to bring these different data sources together in a meaningful way, in a way that is then allowing for making these calculations I mentioned earlier. And this is, of course, here not represented on that chart, but was a kind of bit of work. That work also actually raised, and that might be interesting for you, raised awareness that the holders of different data bases, they had to realize, okay, I have interesting data, but it only can be used if it's if it's sort of unified, if it's being able to match with other data sources. So it's very important to have a consistent reference, and one reference is either a unique identifier that identifies all the buildings that's implemented in Switzerland, and then the utility started actually to use this identifier instead of the address. Or you can use the GIS or the coordinates to make this data mergeable and combinable between others. Okay. Okay, I'm sorry. So the final message here would be the building stock model has a modular approach. It has a methodology and data that is well-founded, actually also in various international projects, not only in national ones, and has and is actually available. So it could be used in other cities, depending on, of course, the form. We are currently thinking within the Climate Kick project how we can make this tool available to other cities, and either we can make it available through a corporation, for instance. We are able to make studies, or we can think of a web-based simplified approach where you can run a simplified scenario. So these are, in brief, the 3 different possibilities that we are thinking of. And more details are then discussed tomorrow in this workshop sessions in the afternoon, where maybe one or the other of you is present as well.